Hello, good day everyone. So, welcome to another video lesson in Statistics and Probability. Still, ang teacher nyo is Ma'am Jenna. So, for today's lesson, we will discuss the central limit theorem. So, tayo ay nasa module 6 na ng inyong SLM. So, for our objectives, number 1, illustrate the central limit theorem. Number 2, define the sampling distribution of the sample mean using the central limit theorem. And number 3, solve problems involving sampling distributions of the sample mean. Okay, so ano nga ba ang central limit theorem? So, in statistics, the given data set represents a sample from the entire population. Kung matatandaan nyo, nabanggit ko before na kung malaki yung population, ang ginagawa lang ng mga researchers ay kumukuha lang sila ng sample from that population, and that sample will represent the whole population. So, using this sample, we try to see the patterns in the data. We then try to generalize the patterns in the sample to the population while making the predictions. So, central limit theorem helps us to make inferences or about the sample and population parameters. So, yung central limit theorem daw ay matutulungan tayo to make inferences or to make conclusions about the sample and population parameters. Okay, so central limit theorem states that the sampling distribution of the mean approaches a normal distribution as the sample size increases. So, habang tumataas yung sample size natin, mas nagiging normal yung ating distribution. So, regardless of the initial shape of the population distribution, pwedeng skewed to the left or skewed to the right, if samples of size n are randomly selected from a population, the sampling distribution of the sampling mean will approach a normal distribution as the sample size n gets larger. So, ibig lang sabihin nun, mas accurate yung nakukuha nating result habang tumataas yung ating sample size o yung ating n. Okay, so the standard error of the mean measures the degree of accuracy of the sample mean as an estimate of the population mean. It is also known as the standard deviation of the sampling distribution of the sample mean, denoted by sigma sub x bar. So, hindi ba sa mga experiments naman, hindi naman siya automatic na 100% na accurate yung ating nakukuhang conclusions or yung results. So, kahit papano meron dyang error. So, ito yung tinatawag nating standard error of the mean. So, ito yung formula na ginagamit natin para malaman natin yung ating standard error. Yung standard error is also known as the standard deviation of the sampling distribution of the sample mean. Kaya kung mapapansin nyo, dito sa ating formula, ang nakalagay dito ay sigma sub x bar. No? Kasi yung standard error is also the same as the standard deviation. Ito ay standard deviation of the sample mean. Diba? So, pareho lang sila. So, kapag kinompute natin ito, malalaman natin yung standard error. No? Where yung sigma, ito, syempre, is the population standard deviation. At itong n is the sample size. Okay, so let us have examples. Determine the standard error of the mean for each of the following sample size n. Given the population standard deviation of 30, round off your answer to the nearest hundredths. Letter A, if n is 5. So, ang given natin dito ay ang ating sample size is 5, the standard deviation is 30. So, using the formula, And then, we have to substitute the given data to the formula. Yung value ng ating standard deviation, population standard deviation, ito is 30. Kaya ito ay 30. And then, yung n natin, yung sample size, is yung 5. So, 30 divided by the square root of 5 is equal to 13.42. So, medyo malaki yung error na yan. Kasi 13.42. Letter B. What if n is 12? No, kanina, ang n lang natin ay 5. So, maliit. Ngayon ay 12. So, again, using the formula, and then, the same yung data natin, yung value ng ating population standard deviation is 30, and then yung n natin, ito yung 12. So, 30 divided by the square root of 12 is 8.66. Okay? Kanina, yung n natin ay 5, ang nakuha nating standard error ay 13 point something. Ngayon naman, ang n natin is 12. Ang nakuha nating standard error is 8.66. So, letter C. What if n is 28? Ayan, mas malaki na yung sample size natin. Again, using the formula, and then substitute, the same lang yung value ng ating population standard deviation, which is 30. And then, yung n natin is 28. So, 30 divided by the square root of 28 is 5.67. Now, dito sa tatlong examples na ipinakita ko, what do you notice dun sa nakuha nating standard error in relation dun sa mga sample size? Diba kanina, ang n natin ay 5, ang nakuha nating standard error ay 13 point something. And then, nung 12 na yung ating standard error, yung ating sample size, yung nakuha nating standard error ay bumaba, naging 8.66. And then, nung yung ating n na ay 28, ang nakuha na nating standard error ay mas bumaba pa, naging 5.67. So, ibig sabihin pala, as the sample size increases, yung ating standard error decreases. No? Mas nagiging accurate yung resulta natin kasi bumababa yung standard error once na yung ating sample size ay lumalaki. So, as the sample size increases, the standard error decreases. Okay, so the central limit theorem is important because it teaches researchers to use a limited sample to make intelligent and accurate conclusions about a greater population. So, natutulungan tayo ng central limit theorem to come up with an accurate conclusions. Now, it also justifies the use of normal curve methods for a wide range of problems. Furthermore, it justifies the use of this formula, okay, when computing for the probability that the sample mean will take a value within a given range in the sampling distribution of X. So, ginagamit daw natin ito kung gusto nating malaman na kung yung ating sample mean ay within ba dun sa given range in the sampling distribution of the sample mean. So, where yung ating X bar is syempre is the sample mean, mu is the population mean, sigma is the population standard deviation, and small letter n is the sample size. Ito yon yung apat na to. And then, yung z natin is the z score or the z value. So, when do you use this formulae? Etong dalawa na to, kailan ba to ginagamit? Kung tatandaan nyo ulit, itong formula to ay ginamit na natin in our previous lesson. Ginamit natin to convert normal values into z values or into z scores. Diba? Ito, yung formula na to, ginamit natin to convert normal values to z scores. Ito, kailan kaya ito ginagamit? So, tignan natin. So, study the illustrative sample problems below. Number 1. Assume that the variable is normally distributed. The average time it takes a group of senior high school students to complete a certain examination is 46.2 minutes, while the standard deviation is 8 minutes. So, sabi dyan, the average time it takes a group of senior high school students to complete a certain exam is tumatagal ng 46.2 minutes. Na while yung standard deviation is 8 minutes, meaning yung 46.2 na to pwedeng madagdagan ng 8 minutes or pwedeng mabawasan ng 8 minutes. Hindi ba yun naman yung use ng ating standard deviation? So, what is the probability that a randomly selected senior high school students will complete the examination in less than 43 minutes? So, ano daw yung probability na yung selected senior high school students ay matatapos nila yung examination in less than 43 minutes? Mas mababa kesa sa 46.2 minutes. So, does it seem that a senior high school student would finish the examination in less than 43 minutes? So, solution for number 1. Step 1. Let us identify the parts of the problem. Ano-ano ba yung mga given? So, ang given natin ay yung average number of minutes, no? Or yung ating population mean, which is 46.2 minutes. Ang ating population standard deviation is 8 minutes. And yung ating sample mean na gusto nating i-prove is 43 minutes. So, ito yung hahanapin natin. The probability that our sample mean is less than 43 minutes. So, yan yung ating step 1. Step 2, use the formula to find the z-score. So, ito yung formula na gagamitin natin kasi kung napansin nyo, dun sa given problem, wala namang ibinigay na value ng n. Tama ba? Walang nakalagay na sample size. Basta ang sinabi lang doon ay group of senior high school students. And wala namang nakalagay doon na yun bang mean na kailangan nating i-prove na yung mean ay nakapaloob doon sa certain range in that given situation. So, ito yung formula na gagamitin natin. Z equals x bar or the sample mean minus population mean divided by the population standard deviation. No? Kumbaga, yung mga normal values dito ay i-convert lang natin into z-score. Okay? So, substitute the value. Ang x bar natin ay 43. 43 minus yung population mean natin, ito is 46.2 divided by the population standard deviation which is 8. So, 43 minus 46.2 divided by 8 equals negative 0.40. So, ang corresponding z-score ng 43 minutes ng ating sample mean is 0.40 sa ating z-score. Step 3. Use the z-table to look up the z-score you calculated in step 2. Ito yung na-calculate natin sa step 2. Has a corresponding area of 0.3446. So, balik tayo dun sa ating z-table. Ito yun, kung matatandaan nyo. So, dun sa ating z-table, ilolocate natin yung negative 0.40. 0.4, ito yun. And then, yung 0.40, 0 yung kasunod niyan. So, dito siya. So, ang value niya is 0.3446. Step 4, draw a graph and plot the z-score and its corresponding area. Then, shade the part that you're looking for. Ang hinahanap natin ay the probability that the sample mean is less than 43. So, ito yung ating graph, no? Yung ating bell-shaped na graph. And then, bakit ang isi-shade natin ay itong part na to? No? Sabi dito, since we are looking for the probability less than 43 minutes, the shaded part will be on the left part of negative 0.40. 40. Yung ating 43 minutes na value ng ating sample mean, ang corresponding z-score niyan ay negative 0.40. Kaya dun sa ating graph, ang ilolocate na natin ay yung nakuha nating z-score, which is negative 0.40. Kaya nandito siya. No? And then, ito yung sinade natin kasi ang hinihingi ay less than. So, ano-ano yung mga less than? Siyempre, yung mga nandito sa left side. So, kaya ito yung may shade. And then, yung nakuha nating value sa ating Z table ay 0.3446. So, yun yung value ng ating shaded area. No? Pero, hindi naman laging, kung ano yung nakuha natin dun sa Z table, yun yung value ng shaded area. Pwede rin kasing, yung nakuha nating value dun sa Z table, siya yung unshaded part. No? Pero, in this case, yung nakuha nating 0.3446, yun yung ating shaded region. Okay? Malalaman nyo naman kung siya yun. Ano kasi ito pag kinonvert nyo sa percent, this is 34.46. So, hindi ba mukha naman itong 34.46? And ano ba itong 0.155? Ito naman yung area nito, yung unshaded, yung kalahati. Di ba? Sabi natin symmetrical yan. 50-50 yan. Di ba? So, kung yung 0.3446 ima-minus nyo sa 50, ito yung matitira, 0.1554. Okay? Okay, so step 5, convert the decimal in step 4 to a percentage. So, hindi ba yung nakuha natin kanina is yung 0.3446. Ito yun, di ba? So, i-convert lang natin yan into percent. So, by moving 2 decimal places to the right. Kaya yung 0.3446 ay equivalent to 34.46%. So, therefore, ito na yung ating conclusion. The probability that a randomly selected senior high school student will complete the examination in less than 43 minutes is 34.46%. So, medyo malaki yan. So, yes, it is reasonable to finish the exam in less than 43 minutes since the probability is more than 1. No? So, yan yung ating conclusion. Okay, so, ito ay extension ng ating example number 1. No? So, kadugtong to. So, sabi dito, if 50 randomly selected senior high school students take the examination, what is the probability that the mean time it takes the group to complete the test will be less than 43 minutes? So, in this example, meron nang involved na sample size kasi meron ng 50 selected senior high school students. And ang tinatanong na dito is yung probability that the mean time is, nandun ba siya sa range ng less than 43 minutes? So, does it seem reasonable that the mean of the 50 senior high school students could be less than 43 minutes? So, solution for 1A, step 1, same lang po yung steps natin. So, step 1, identify the parts of the problem. So, ang given natin dito, syempre, still, ang population mean natin, o ang average natin ay, ganun din dun sa example number 1. Yun ay 46.2 minutes. Yung ating population standard deviation na 8 minutes. Yung ating sample mean, 40 minutes. And, ang nadagdag lang is yung ating sample size na 50 students. So, still, we're going to find the probability that the sample mean is less than 43 minutes. Okay. So, step 2 natin. Use the formula to find the z-score. So, in this case, ito yung formula na gagamitin natin. No? May kasama na siyang sample size n. So, substitute the values. Ang ating sample mean is 43 minus population mean 46.2 divided by yung ating population standard deviation is 8 over the square root of the sample size, 50. So, kung i-compute nyo ito using your calculator, ang dapat na makukuha nyo dyan ay negative 2.8. Okay, step 3, use the z-table to look up the score you calculated in step 2. So, negative 2.83 has a corresponding area of 0.0023. Ayan, ito yung ating negative 2.8. Diba? Nung tinukuro ko sa inyo kung paano gamitin ito, yung first two digits ay dito natin titignan. So, yung negative 2.8. And then, yung third digit ay dito na sa sa top row, which is 0.03. So, ang value ng negative 2.8 is 0.0023. Step 4, draw a graph and plot the z-score and its corresponding area. Then, shade the part that you are looking for. Ang hinahanap natin is the probability that the sample mean is less than 43. So, eto siya. Okay, since we are looking for the probability less than 43 minutes, the shaded part will be on the left part of negative 2.83. So, in this case, yung corresponding z-score naman ng 43 natin ay negative 2.83. Kagaya ng sabi ko, every time nagagawa kayo ng graph o ng bell shape ng normal curve, kailangan yung z-score na yung ilolocate natin dito. So, ito na yung negative 2.83. And since ang hinahanap natin ay less than 43, so ang shade natin syempre ay yung nasa gawing kaliwa. No? Ito yung 0.023. Kung mapapansin nyo, tama lang na itong nasa kaliwa yung may shade. Kasi yung 0.0023 ay napakaliit lang yan. Kaya ito lang dapat ito lang yung, tama lang na ito yung part na may shade. Ano naman yung 0.4977? Again, symmetrical yan, 50-50. So, pag ginad nyo yung 0.4977 or kapag sinubtract nyo yung 0.0023 sa 0.5, ito ay magiging 0.4977. Kumbaga, ipinakita lang yung ano yung area ng unshaded at ano yung area ng shaded part. Okay? Importante na malaman nyo kung aling part yung isi-shade, yung gawing kanan ba or yung gawing kaliwa. So, kapag less than sa kaliwa, pag greater than sa kanan. Step 5, convert the decimal in step 4 to a percentage. So, hindi ba ang nakuha natin kanina ay 0.0023. Sa pagko-convert ng decimal to percent, di ba minumove lang natin ng 2 decimal places papunta sa kanan. Kaya siya ay 0.23%. So, therefore, the probability that a randomly selected 50 senior high school students will complete the examination in less than 43 minutes is 0.23%. So, no, it's not reasonable since the probability is less than 1. Kung titignan nyo to kasi wala pang 1% yan. So, napakaliit niyan. So, therefore, hindi siya reasonable. So, ang mean kasi natin kanina is 46 point something eh. Tapos, binaba pa siya, less than 43 minutes pa. So, parang hindi na siya reasonable, ano? Kaya siya ay, no, it is not reasonable since the probability is less than 1 or less than 1%. Another example, number 2, an electrical company claims that the average life of the bulbs it manufactures is 1,200 hours with a standard deviation of 250 hours. So, again, standard deviation 250 hours. Pwede madagdagan yung 1-2 ng 250 hours. Pwede rin siyang mabawasan ng 250 hours. If a random sample of 100 bulbs is chosen, ayan, merong sample size na 100 bulbs. So, alam nyo na kung anong formula yung gagamitin. What is the probability that the sample mean will be between 1,150 hours and 1,250 hours. So, eto na yun, no? Gusto nating i-prove kung yung ating sample mean ba ay nasa pagitan ng 1,150 and 1,250. And may given tayong sample size na 100 bulbs. So, solution, step 1, identify the parts of the problem. So, mga given natin, the population mean, yung 1,200 hours. Yung ating population standard deviation, 250 hours. Yung sample size, 100 bulbs. Yung ating X, yung ating sample means, dalawa yan, 1,150 hours and 1,250 hours. Ang unknown, the probability that the sample mean is in between 1,150 and 1,250. So, step 2, syempre, we use the formula to find the z-score. So, ito ulit yung formula ang gagamitin kasi may involved na sample size. Since dalawa yung given natin, dalawa rin yung computation na gagawin nyo. No? Yung una, yung 1,150 muna yung gagamitin. Yung pangalawa, yung 1,250. Ito lang namang x bar ang mapapalitan yung sample mean. So, the sample mean is 1,150 minus the population mean, 1,200, divided by yung ating population standard deviation, 250, over the square root of the sample size na 100. So, z is equal to negative 2. So, another one, kung ang ating sample mean ay 1,250, ang ating makukuhang z-score ay positive 2. So, meron tayong dalawang values, negative 2 and positive 2. Step 3, use the z-table to look up the z-score you calculated in step 2. So, z equals positive negative 2 has a corresponding area of 0.0228 and 0.9772. So, eto siya. Ito yung value ng negative 2. Okay? It's 0.0228. At ito naman yung value ng positive 2 na 0.977. Step 4, draw a graph and plot the z-score and its corresponding area. Then shade the part that you are looking for. So, we are looking for the probability that the sample mean is in between 1,150 and 1,250. So, ito yung ating graph, no? So, kagaya ng sabi ko kanina, hindi naman porke yung nakuha nating value dun sa z-table natin ay yun na yung may shade. So, tingnan nyo to. Diba, ang nakuha nating value for negative 2 is 0.0228. Pero, since itong value na to ay maliit lang, kung i-convert nyo to sa percent, ito ay 2.28% lang. So, ibig sabihin, no, alam nyo na agad na hindi siya yung malaking part kasi 2.28% lang yan. And itong part na to, ito yung ating, ito yung negative 2. Negative 2, ito yung positive 2. So, bakit ang may shade is yung nasa gitna? Sabi dito, since we are looking for the probability between 1,150, ito yung nagrepresent sa negative 2, nare-represent yan ng negative 2, and 1,250, ito naman yung positive 2. Siyempre, the shaded part will be between negative 2 and positive 2. So, kaya ito yung may shade. And then, yung nakuha nating value for positive 2 kanina na 0.9772. So, in percent, this is 97.72%. So, ibig sabihin, yan yung malaking bahagi. So, yung 0.9772 ay yan ay mula dito hanggang dito sa positive 2. Lahat ng yan ay 97.72%. Pero, kasi kung i-add nyo yung 0.9772 tsaka yung 0.0228, yan ay equal to 1. Ano? Kaya yung 0.9772 ay mula dito hanggang dito sa 2. And then, yung remaining unshaded part, ito yung 0.028. Pareho lang sila ng, yung end tail, na pareho lang sila ng value. And syempre, yung nasa gitna natin, pareho lang din sila ng value. Bawat, ito yung kalahati nito ay 50. So, 50 minus 0.0228. 0.5 pala, minus 0.0228, 0.4772. 0.72. Ganon din dito sa kabila. Para malaman natin ilan yung area ng shaded region. Step 5, convert the decimal in step 4 to a percentage. Ang i-convert natin sa decimal ay yung area ng shaded region. So, in this case, the probability that the sample mean is in between 1,150 and 1,250. So, syempre, yung dalawang shaded region, pagpaplasin lang natin silang dalawa or i-times 2 nyo. No, 0.4772 plus 0.4772, this is equal to 0.9544. Or in percent, again, move nyo lang ng dalawang decimal place to the right, this is 95.44%. Therefore, the probability of randomly selected 100 bulbs to have a sample mean between 1,150 hours and 1,250 hours is 95.44%. Okay, so that ends again my video lesson for today. Again, credits to the module development team. Again, sana ay nakatulong ang video lesson na to para ma-accomplish nyo yung mga activities na nandun sa inyong module. So, I will end this video lesson with a quotation from William Paul Thurston. Sabi niya, mathematics is not about numbers, equations, computations, or algorithms. It is about understanding, no? So, kung sa video lesson na ito, naintindihan nyo yung discussion natin, ibig sabihin yan, you are learning. So, hindi mahirap maintindihan ang math subject kung nasa sa inyo yon, ano, nasa sa inyo yung kung talagang gusto nyong maintindihan siya, pero kung niisip nyo agad, mahirap ang math, mahirap talaga siyang maintindihan. So, once na naintindihan nyo yung lesson natin, ibig sabihin kayo ay natututo. Okay? Once again, thank you and I'll see you again on my next video lesson.